Unit 2 Chemistry, Chapter 16, Part 1. Looking at a second type of reaction that happens in water now, which is redox reactions in water. Okay, so a redox reaction is when electrons are moved from one substance to another. Sometimes this is a physical moving of electrons, sometimes it's more of a theoretical movement because the charge has changed. So basically, in a covalently bonded molecule, we've changed what share of electrons they've got. In any redox reaction, we've got to have two things. We've got to have something that loses electrons and something that gains. The process of gaining electrons is called reduction. The process of losing electrons is loss. We use this is oxidation. We use this little acronym, oil rig. Oxidation is loss, reduction is gain. Okay? And oxidation and reduction are both half of the reaction. So we call them half reactions, and they have to happen simultaneously. An electron can't just float around on its own. It has to go straight from the oxidation half reaction to the reduction half reaction. Now the reason it's called oxidation is because initially this term was used to just talk about those reactions where things were reacting with oxygen. What they found was actually in those reactions we were getting a transfer of electrons, and then they found there were lots of similar reactions where electrons were transferred but didn't involve oxygen, but the name stuck. Now, the reason we think about redox reactions is to keep track of the movement of electrons or the movement in charge in a reaction. Okay? If there's no change in charge, then we call it a metathesis reaction. And there are lots of different reactions where the arrangement of atoms is changed, but there is no change in the charge of anything. So one of the ways we keep track of whether it's a redox reaction or not is to look at the oxidation number. The oxidation number is the charge that an atom feels when it's in a compound. If the oxidation number goes up when a reaction happens, then oxidation has occurred. If an oxidation number goes down, then reduction has occurred. Because remember, electrons are negatively charged. So if you gain an extra electron in reduction, then that's going to bring your charge down. And the sum of all the oxidation numbers is equal to its total charge. So for a neutral molecule, the sum has to equal 0. For a charged ion, like SO4 2-, the charge would have to equal 2-. So we've got some simple rules that we follow. The first is that if it's a pure element, all on its own, so something like O2 or Fe or Ne, all of those, the oxidation number is going to be equal to 0. If it's a simple ion, so we're talking here are metals that are in group 1 and 2 and group 13, and we're talking about our non-metals that are in groups 15, 16, 17. They make simple, predictable charged ions, and we know that the oxidation number is the same as the charge. So sodium has a charge of 1+, so its oxidation number is +1. If we're something in the transition group, then the charge is the same as the valency. So iron 2+ has an oxidation number of 2+. Iron 3+ has an oxidation number of 3+. So far, so simple. Fluoride always has an oxidation number of -1 when it's in a compound. Hydrogen always has an oxidation number of +1 unless it's in a compound with a metal, in which case it's -1. Oxygen is always -2, except for two situations. If it's in a peroxide, and H2O2 is the only peroxide you're going to come across in VCE chemistry. So in a peroxide, its oxidation number is -1. And in F2O, because fluoride has to be -1, oxygen therefore has to be +2. All the other elements you can work out really just using the hydrogen and the oxygen, and the fact that if it's a neutral molecule, the overall charge has to be 0. If it's a polyatomic ion, like your carbonates or your sulfates, then the oxidation numbers have to add up to the overall charge. So an example. Oxygen, O2, free element, so its oxidation number is 0. H2O. Well, hydrogen is pretty much always +1, so it's +1. Oxygen is -2. Now notice here, I said hydrogen's +1. The fact that there's two of them doesn't matter. We're interested in the oxidation number of a single hydrogen in there, not the total oxidation number of all the hydrogens. Okay? CO2. Now here's one that wasn't on our list, carbon. But we know that oxygen has an oxidation number of -2. We know that the overall charge has got to be 0. So there's two oxygens, so 2 times -2 is going to give us -4. To get from -4 to an overall charge of 0, carbon must be +4. Okay? Same idea here with sodium sulfate. So sodium's a simple ion, it's in group 1, so its charge is +1. There's two of them, so it's giving a charge of +2. Oxygen is -2. There's 4 of them, so that gives us -8. So we've got -8 and +2, which gives us -6. To get us back to 0, sulfur has to be the difference, so that has to be +6.